Hello, this is Mrs. Amo, and today we are learning about plate tectonics. As you can see here, the Earth is made up of three layers. The core, which is actually two layers, with an inner core and an outer core, the mantle, and the crust, which is where we live. The Earth's crust. Our Earth's crust is made up of two parts, the continental crust, which is where the land is, and the oceanic crust, which is covered by the ocean. The continental crust is the crust beneath the Earth's continents. This crust is less dense and thicker than the oceanic crust. Remember that density is whether or not an object will float. When talking about our continental crust or land crust being less dense than the oceanic crust, what we mean is the continental crust can potentially float on the oceanic crust. This will be important later when we're talking about the tectonic plates. The continental crust is made up of granite, which is less dense because it's high in silicon and oxygen. Next, we have the oceanic crust. This is the crust beneath the Earth's oceans. It's more dense and thinner than the continental crust. It's made up of basalt, which is dense because it is high in iron and magnesium. Take a look at this picture of our globe. Have you ever noticed or thought about the fact that the 7 continents might look a little like pieces of a puzzle? Take a look at it for a minute and try to see if the continents fit together. Maybe they do, maybe they don't. Pangea. Pangea is a theory that all continents do in fact fit together to form a supercontinent. This theory came about millions of years ago. Due to plate tectonics, the continents drifted apart into what the world looks like today. So on the left there you see a picture of all the continents nicely fit together. Then if you move over to the picture on the right, the continental drift of the plates, it starts with Pangea 225 million years ago, and you can see how the plates separated to get what the Earth looks like today. Plate tectonics. The word tectonic refers to building or construction, according to dictionary.com. The Earth's crust has 7 major plates and 10 minor plates, which can move in various directions. For this class, we will focus on the 7 major plates. When the plates move, they often collide, pull apart, or scrape against other plates. Think about this for a minute. What could happen to the structure of the Earth when these plates collide, pull apart, or scrape against the other plates? Now I'd like you to take a minute, pause the slideshow, open up your classroom notebook, and actually answer this question. Look at this map and locate the 7 major tectonic plates on Earth. The 7 major plates are the Pacific Plate, the North American Plate, the Eurasian Plate, African Plate, Antarctic Plate, Indo-Australian Plate, which is Australia and Indian Plate together, and the South American Plate. Please locate the lithosphere on this cross section of the Earth. Each plate is made up of a rigid lithosphere. The crust and part of the upper mantle make up the lithosphere. Now locate the asthenosphere. Go ahead and say it, asthenosphere. Tectonic plates float on the asthenosphere. The asthenosphere is a region of molten rock beneath the surface of the planet. Notice the asthenosphere is directly under the lithosphere. So how do plates move? Take a look at this image and think about what you have learned so far. Apply your knowledge to explain how tectonic plates move, or how you think they move based on what you've learned. Go ahead and write your answer in your classroom notebook. Plate boundaries. There are 3 types of plate boundaries. Divergent plate boundaries, as you can see to the right, are the spreading of the plates, two plates spreading apart. As the plates move apart, the material is erupted to fill the gap. Next, we have convergent plate boundaries, where two plates collide together. The last type of plate boundary is a transform fault plate boundary, where two plates slide past each other. Take a look at these examples of divergent plates. If you look at the spreading ridges, as the plates moved apart, material was erupted to fill the gap. The material then hardened, and what we get is something like what you see in these pictures. Two plates colliding, or convergent plate boundaries. There are three types of collision plate boundaries: continent to continent, continent to oceanic crust, and ocean to ocean collision. So remember at the beginning when we talked about the fact that there are two types of crust, a continent crust and an oceanic crust. So these convergent boundaries can form between those two types of crust. Take a look at what happens when you get a continent to continent collision. You may notice this is the building of mountains. If you look at the illustration on the top left hand, you can see the two plates colliding together, which is pushing up the land to form a mountain. Continent to oceanic collision. This might interest some of you. When a continent collides with an oceanic crust, the oceanic crust goes under or subducts, creating a volcano. A subduction zone, where the X's on this illustration is a subduction zone. The oceanic lithosphere subducts or goes under the continental lithosphere. The oceanic lithosphere heats up and the melted substance rises, forming a volcano. Ocean to ocean collision. Again, we see volcanoes emerge, but this is when two oceanic plates collide. A subduction zone is formed when two oceanic plates collide and one goes on top of the other. The bottom plate is subducted down into the mantle, forming a trench. These trenches form the deepest parts of the oceans. Here is an illustration of a transform boundaries, when plates slide past one another, causing a fault. If you look at the illustration to the left, on that fault line, this is where we can get earthquakes. One of the most famous faults is in California. It's called the San Andreas Fault. Practice what you have learned and use your map reading skills to understand this slide. Using the key below the slide, find some potential earthquake activity. I want you to take a minute and think about how living in this area might affect your life. Last but not least, pop quiz. Get out your classroom notebook and answer these 5 questions. Number 1, the theory of a subcontinent is called. Number 2, two tectonic plates sliding against each other is called. Number 3, what is it called when one plate moves under the other? Number 4, what are the 3 layers of the earth? Number 5, when 2 plates collide into one another, it's called what? Please write your answers in your notebook and we will review them tomorrow. Thank you so much for listening to this presentation. I hope you enjoyed it. Have a wonderful day.